Hello, everyone. Hope everyone is well. So today I am going to code a smart contract called Smart Interest Account. This is a continuation from Quest 1. Today I'm going to do Quest 2, which is part of the Questbook challenge. So you can see Quest 2 is getting a real interest rate. So just a brief explanation of what are the requirements for Quest 2. So basically to complete Quest 2, we have to code a smart contract that allows users to be able to deposit amount to the bank account that we created and allows users to earn real interest rate. Remember in Quest 1, there was no real interest rate because the contract was not able to create interest out of thin air. So in Quest 2, what we are going to do is to get real interest rate from another decentralized application called Compound. And that means we will have to interact with the Compound application. And we will be deposit amount to Compound through our smart contract. And also we are going to withdraw amount from Compound and return it, transfer it back to the user if the user chooses to withdraw the deposit. So without further ado, I will now start going through the code. So the first section, you can see it is there is an interface. This is an interface which provides the signature of a function at Compound. So these are the functions that are available at Compound that we will be using. And interface, typically interface does not have the implementation of the function. So what you see is you can think of it like a summary of a function. It doesn't have the implementation. If you want to look at the implementation, you can go to Compound documentation. I can just quickly show you that. So yeah, this is a Compound documentation. And then you can find out how those functions are implemented. So right now we are going to use the interface, and this is how we are going to interact with Compound through the interface. And I'll go through that later. The next section is the IERC20. Actually, we don't need to use this. We are going to use this in Quest 3. So you can ignore this for now. Okay. The next section will be our smart interest account contract. So first of all, we still have the same function, the add balance function, but you see I've added an additional line here, which is to allow the contract to send amount to Compound. And just now I mentioned that we are going to interact with Compound. And how exactly are we going to do that? So you see we have the Compound ETH address here. And you can find this address from the Compound documentation. This is the ring B address. If you want to deploy to Robston, you will have to use another address. So I deploy to ring B because it's just faster to deploy. And then you have to define the object as such. So this is to initialize the Compound contract so that we are able to interact with it from our smart contract. So this is how you do it. you put in the address of the compound ETH and you initialize it this way. And once you have done that, you will be able to use the function that are within this interface. So right now we are using this mint function, and what this mint function does is that it will allow our smart contract to deposit ETH to compound, and in return, our smart contract will receive compound ETH, and this compound ETH will accumulate interest, and the value will increase with the longer time we deposit the amount with compound, because the interest will compound. So when we withdraw the amount from compound, our smart contract will redeem the ETH from compound by returning the compound ETH, and we will be able to withdraw the ETH that we have deposited plus interest. And that this time, this is real interest. The next function is called get contract balance. As the name of the function suggests, it allows us to get the contract balance. And the next function is called get compound balance. So this is the amount of ETH that we have deposited as a user plus the interest. So you can see that we will multiply the compound ETH by the exchange rate. So this is basically a conversion rate to convert our the amount of ETH that we deposited with the interest rate. Okay, next function is get total compound ETH amount. And then we have this conversion rate. So why do we need this conversion rate? This is so that we are able to, when we withdraw amount, later on I'll talk about withdrawing partial amount. So when the user withdraw partial amount, we have to be able to calculate how much does that translate into compound ETH. Because remember, the amount that we deposited will not correspond one-to-one to the compound ETH, because compound ETH will accumulate interest. So it won't be one-to-one conversion, right? So if the user wants to withdraw certain amount, we will have to calculate how does that translate into compound ETH. And this is basically what this conversion rate is doing. Get balance in way, this is for user to be able to find out how much balance he or she has available within the contract. And we will be using this to determine how much the user can withdraw. So now let's look at the withdraw function. So this withdraw function allows a user to specify how much he or she would like to withdraw from the simple interest account, smart interest account. And it requires that the amount that is being withdrawn should be less than the amount that the user has available plus interest. If it's more than that, then there will be an error overdrawn. And this amount to redeem in compound ETH, this is basically what I just mentioned. The user, we have to be able to convert the amount that the user wants to withdraw into compound ETH terms, and then we send that to compound to redeem the amount of ETH plus interest. So Before we actually go ahead and withdraw the amount, we have to make sure that we have updated the user's balances. This is for security reason, as I mentioned in the previous video. So we should update the amount before we start calling the compound, calling any external contract. So the next line, basically, we record the amount of the contract balance before redeem and amount after redeem. And this is so that we are able to calculate how much has actually been redeemed. And this line is showing is basically the line that executes the redeem amount from compound action. And once we have redeemed the amount from compound, the amount will be deposited to our smart contract, right? We need our smart contract to send the amount to the user. And this is what this line is doing. Is basically we have to specify payable, because if we were to be able to send it to the user, it has to be a payable address. And this value will be the amount that has been redeemed. And it will be, if the transfer is successful, it will return the amount that has been redeemed. If not, it will show failed to send either. And lastly, remember, for this smart contract to be able to receive amount, we should put this fallback function. In this case, is a receive function for the smart contract to be able to receive amount paid into the contract. So that's all for today. I am going to post a link of the full code, which is available at my GitHub down below. So if you want to see the full code, feel free to visit the link and get the code. If you have any questions or comments, feel free to post it in the comment section. And thank you for watching. Thank you very much for your time. I'll see you soon. Bye.